In the last section, we were talking about the addition property of equality. This section is about the multiplication property of equality. I can start us off by using a similar example. If I start with a statement that is clearly true and multiply both sides of this equation by the same number, I end up with another statement that is just as true. As with the addition property of equality, the original statement can be a number is equal to a number or a variable is equal to a variable. Clearly, x has to equal x. So twice as much as x must equal twice as much as x. Remember from the last video that I can inherently say that x equals x, because once its value is set, whether we know it or not, it has to be the same for every instance you see of that variable. What if I start with something like this, though? X equals 3. This equation is a statement that the value x takes on is 3. X has a value and it's 3. So this is a true statement. So I can multiply both sides of this equation by the same number, and I'll get another statement that should be just as true. It doesn't actually matter what you have on either side of your equal sign. For example, if I have 5x equals 30, and I multiply both sides of the equation by 2, I get a new statement using the associative property of multiplication. 10x equals 60. The thing is, this isn't really helping us very much. Our equations are getting bigger and bigger instead of smaller. If I give you 5x equals 30 and ask you for the solution to that equation, multiplying both sides by 2 isn't going to help. Let's see if we can find a number to multiply by both sides of this equation that will end up leaving the number in front of the x being equal to 1, so that we have 1x equals whatever the value is. The number that I need to multiply by 5 so that the result of that multiplication is 1 is the number 1/5. If I multiply the left-hand side of my equation by 1/5, I must also multiply the right-hand side by 1/5. Now I have the 1 that I want. 1/5 of 5 is in fact 1. What's 1/5 of 30? It's 6. So x equals 6. I can do all this multiply both sides business as much as I want, but to find the solution of the equation, I need to pick the right number to multiply both sides by. Here's another example. 4a equals 24. I could multiply both sides of this equation by 6 or 10 or 5/9 or any number I want. That's a legal move, but it's not going to help us much. To be useful, I need to find the number I'm going to multiply by 4 so that the result of that multiplication is 1. That way I'll have 1a on the left-hand side. So what number is that? What number times 4 is 1? 1/4 times 4 is 1, because 1/4 of 4 is 1. If I do it on the left, I must also do it on the right. 1/4 of 4 is 1 times a equals 1/4 of 24. 1/4 of 24 is 6. So in this question, a equals 6. What happens if the equation isn't 4a equals 24, but negative 4a equals 24? Well, over here, I multiplied my 4 by 1/4, because that's the multiplication that gave me 1. what number do I have to multiply negative 4 by to get positive 1? That number is negative 1/4, because a negative times a negative is a positive, and then the 1/4 times 4 will still give me the 1. What I do on the left-hand side, I must also do on the right-hand side. Let's finish this one out. A negative times a negative is a positive. 1/4 of 4 is 1 times a equals a positive times a negative is a negative, and 1/4 times 24 means 1/4 of 24, and that's still 6. The only difference is that because I multiplied by a negative 1/4, I ended up with a negative 6. I don't need a positive sign, and I don't need a 1. So my answer is a equals negative 6. What was the difference? In this question, I was multiplying 4 by a, so I undid that multiplication by multiplying by positive 1/4. In this question, I was multiplying negative 4 by a, so I undid that multiplication by multiplying by negative 1/4. Let's take one more look at this problem, because some of you may have seen problems like this before and have a different approach to solving them. Here, a is multiplied by negative 4, so to get a completely by itself, I need to undo that multiplication. One way to do it is to multiply by negative 1/4. Another way to do it is to divide both sides by the number that's in your way, the negative 4. Now I have negative 4 divided by itself, which is 1, times a, equals 24 divided by 4 is 6, and a positive divided by a negative is a negative. I don't need the 1. My answer is still a equals negative 6. This approach is fine, but there are times when it's actually easier to multiply by a fraction than it is to divide by a whole number. Well, let me show you what I mean. Let's look at the problem negative 3/5 times x equals 9/5. What number do I need to multiply by negative 3/5 so that the result of that multiplication is 1? Well, for starters, it needs to be a negative number because a negative times a negative is a positive. To get 1, I need a number divided by itself. I've already got a division going on here. How can I write a number that's a number divided by itself by multiplying this fraction by another fraction? The answer is that if I multiply the top by the bottom number and the bottom by the top number, I'll end up with a negative times a negative is a positive. 5 times 3 is 15. 3 times 5 is 15 times x. And 15 divided by 15, well, that's 1. This becomes 1x, or just x. Now, I've done this problem a little out of order because I wanted you to see this process. When I multiply the left-hand side by negative 5/3, I need also to multiply the right-hand side by negative 5/3. Doing this multiplication of fractions, I have a positive times a negative is a negative. 9 times 5 is 45, and 5 times 3 is 15. So it looks like my answer is x equals negative 45 over 15, except that this fraction can be reduced. 45 and 15 are both divisible by 5. I can tell because they both end in 5. So if I divide both the top and the bottom of this fraction by 5, I get 45 divided by 5 over 15 divided by 5. Be careful here not to forget the work that you're doing includes a negative. This is a negative fraction, so a reduced version of it should also be a negative fraction. Now, if you can see straight to the fact that 9 divided by 3 is 3, that's great. But if you can't, think division one more time. 9 and 3 are both divisible by 3. And of course, 3 over 1 is just 3. Again, if you're comfortable with working with fractions, you may be wondering why I went to all that trouble, when it's obvious that I could have done my reduction here. If it's obvious to you, that's great, but it may not be obvious to everybody, so I did it the long way. Let's take a look at how we can arrive at the same answer by reducing the fractions as we go. First of all, let me point out that I'm going to have a positive times a negative, so my answer is going to be negative. The next piece of the puzzle is to find any common factors in the top and the bottom. 5 goes into 5 once, and 5 goes into 5 once. 3 goes into 9 3 times, and 3 goes into 3 1 time. Now when I do my multiplication, I end up with 3 times 1, which is 3, and 1 times 1, which is 1. But this was a positive times a negative, so my answer is negative. 3 over 1 is just 3. Negative 3 over 1 is just negative 3. Ideally, I should write my answer as x equals negative 3 to show that I found the value for x. That's what I was looking for. I can write just negative 3. This particular problem only has one variable in it, and the variable only has one possible value. It's just good practice to write x equals negative 3 instead of just negative 3. Here's a question. 5 plus 8 equals 10x plus 20x minus 4x. I can't solve this equation for x just yet. I need to work the problem down so that x only appears once. All we need to do is combine like terms, and in fact, this problem isn't quite as difficult as it may appear at first. All of my constants are already on the left-hand side together, and on the right-hand side, all I have is x's. So all I need to do is add them together. I have a stack of 10 x's and 20 more here, that's 30 x's. If I start with 30 x's and then take away 4 x's, I end up with 26 x's. Now that I've got all the like terms combined so that x only appears once, I can use the same trick as I was using before. Find the number that when I multiply it by 26 will give me a product of 1. This time my x's are on the right, but that's okay. As long as I choose the right number and multiply both sides of the equation by that same number, I'm okay. The number I need to multiply by 26 to get 1 is 1 over 26. If I multiply by 1/26 on the right-hand side, I must also multiply by 1/26 on the left-hand side. Here I now just have x. And on this side, I have 1 times 13 over 26 times 1. That, of course, reduces. 13 goes into 13 once, and 13 goes into 26 twice. So 13 over 26 is the same as 1 over 2. My final answer? X equals 1/2. I could just as easily have written 1/2 equals x for my final answer. They're both correct. I want to take one last look at this same question. I'll start with it in this form. As we talked about before, some of you may be more comfortable just dividing both sides by the same number, and that's fine. Be careful that you divide by the right number. I'm actually allowed to divide both sides by 13 here, but watch what happens when I do that. Divide both sides by 13 here, and I get 1, because 13 goes into 13 once. 13 goes into 13 once, but it goes into 26 twice. So the right-hand side of my equation is now 2x. I haven't isolated x. I've done nothing wrong, it's just that I haven't finished the problem. I'm going to go back and show you how I would have done this. But notice that since I'm trying to isolate x, I can still remedy the situation by now just dividing both sides by 2. I get 1/2 equals x. That's what I was after. Let's go back to this version of the question. 13 equals 26x. Since x is the thing I'm trying to isolate, it's the 26 I want to get rid of. So let's divide both sides by 26, not 13. Now I can cancel there, and I get x equals, and if I reduce my fraction, I get 1/2.